Hello, everyone. Welcome. Thanks for coming to Dodging Bullets, automated testing in Rollerdrome. Today, we're going to talk about, assuming my clicker works, I'm going to hit the space bar. We're going to talk about the benefits of automated testing, why I think you should be using it in your project. I want to really infuse you and get you excited to leave this talk and go start implementing stuff on your own projects. There you go, benefits. Now it's working. I'm going to cover a little bit about how to get started with automated testing. Things you should do to get yourself up and running. However, this is not a tutorial. I'm going to be relatively agnostic about engines and about testing frameworks, although I am going to show you some Unity code. Most of the stuff we're going to talk about is going to be general high-level stuff. And we're going to do that in terms of looking at the game Rollerdrome and how it used automated testing to get to shipping and the three main approaches that we used. And we're going to order these in a kind of bang for buck manner. So we're going to take the real simple little things you can try now that'll give you a really big return on investment before the end of the project, as well as, and then slowly scaling it up. So you could leave at any point in this talk and once you've reached your threshold for how much investment you want to make and you'll have good stuff, please don't leave. I'm Andrew. I was the lead programmer on Rollerdrome. I've done a bunch of automated testing throughout my career. I also chair the automated testing stuff at GDC every year. If you want to go to this website, autotestingroundtable.com, you'll find not only a Discord where you can meet other like-minded automated testers, but also a tremendous amount of resources, Trello boards full of learning resources that you can use to get yourself started. This clicker is not very good. Here we go. I'll get the hang of it. Rollerdrome came out last year in August. Reviewed really well, won awards. The important thing you have to understand for this talk is that it's Tony Hawk with guns or Doom on roller skates. It's an action third-person game where you're running around shooting people. We'll get into a little bit more of the context of it later, but it doesn't really matter what kind of game you're making. I don't think there's a particular game that's well suited to automated testing versus another type of game. So before we start, let's talk a little bit about what automated testing is. You'll find it's a field that's got very few nouns, but lots of definitions. No one can agree what each particular word is and what it means. So I'm going to give you my definitions throughout this talk. Hopefully it'll agree with the definitions of people who already might have some experience in this area and agree with the further research you're going to do after this talk. So to me, my definition of automated testing is that it's developer-owned automation that accurately verifies a feature works as intended. Let's break that down a little bit. So developer-owned, that means the person who implemented this feature or fixed this bug is the one responsible for implementing the test. That's going to give you much deeper, more incisive tests because this person understands the feature and how to exercise it, as well as giving you a single point of contact when this feature has to be extended or fixed later on so they can update the tests in line with that. Automation, that means it can return usable results without being watched. If you've got a 14-page Confluence doc on how to run your automated tests, that includes like guessing command line parameters, or if you're expecting your programmers to run their tests before they push to source control, then they're not automated. Sorry, they're just tests. You need to be able to run these anytime and anywhere is often your build server or continuous integration server, and anytime is all the time. Accurately. This means a couple of things. Your tests have to be accurate. If they're not accurate, you're going to start to degrade trust in them, and people are going to stop using them, and they're stop providing value to you. This can mean a couple of things in practice, like being deterministic. You don't want tests that fail some of the time or in some places, but pass in other places. And you want your tests to only fail when the feature that they're testing is failing. And you don't have, and if that feature is failing, you want the test to fail. That's false positive and false negative. Those both should be true. If you get too many of one, then your tests start to become untrustworthy. And intended. I'm not saying anything here about what tests should be testing in your game. The intention is up to you when you approach your game, what kind of tests work for you. I want to break down some myths. Some people might have come in with some preconceptions about what automated testing is. So I want to look at that first before we dive into the nitty-gritty details. And the first one is that You have to do test-driven development. Automated testing and test-driven development are the same thing, and they're not. For people who don't know what TDD is, it's the process of writing a failing test before you've even written the code. So you're writing a test, seeing it fail, then writing the code and seeing it pass. People get very excited both ways about TDD, about using it and not using it. I'm not going to come down on either side of the fence here. I'm not going to spend this talk talking about it. Everything here is kind of agnostic about whether you're doing TDD or not. All tests are unit tests. This is another example of that noun confusion. People seem to think that unit test is just a function that is a test, but a unit test is a specific thing that tests a very, very small piece of code and normally executes very, very, very quickly. There are tests that might execute more slowly. There are tests that might test more code. Those aren't unit tests. Most of the things we're going to be looking at today aren't unit tests. You have to start automated testing early in your project. That's not necessarily true. I'm going to show you stuff today, 1 or 2 things that you can do with a couple of weeks to beta, still get that return on investment. You have to go whole hog, that you have to do automated testing everywhere on your project, that you can't do it anywhere. And that's not true either. I'm going to show you little bits and pieces you can do. And in fact, we didn't test the whole of Rollerdrome. We test a few specific areas. And the final myth is a big one, so I'm going to break it down as its own slide, and that's that writing tests is a luxury. But it's all very well for us with budget and with the people to go writing tests. But us, we have to be nimble and small and fast, and we have to focus on gameplay, and that's where we're going to spend our time, not on writing tests. And I think that's a fallacy. I'm going to try to explain to you why. If we look at this, get my laser pointer working. You can all see that, yep. If we look at this, this is a typical life cycle of a bug in a normal code base. You're going to add a bug. It's going to go into source control. It's going to sit there for a while. You're going to have to wait for it to get into build maybe. And then you're going to have to wait for something to happen, for your bug to manifest. For maybe it's a bug that only happens 1 in 10. Even once it happens, maybe you then have to get them off to QA and get QA to nail down some repo steps. Then that's going to have to go into Jira or something and come to the top of your priority list, which might be days or weeks later. And finally, you have to remember how this code works. Like last time you touched this was weeks ago, and now it's come back to you with a bug. It's going to take you time to get back into the zone, to get that fix in, and maybe you won't even be able to do a really good fix because you'll have already architected the code in such a way that it's hard to get the proper fix for this thing. Instead, if we look at a similar loop for a fully tested game, it's much smaller. You're adding a bug, you have a test failure. Maybe it comes locally, maybe it comes when you push to the build server, but it's within hours or minutes. And then you can fix it. You're still in that headspace. Maybe you're early enough that you can architect the whole feature to make sure this bug gets fixed and never comes back. That's a much tighter loop. And yeah, you've added more code because you wrote a test to go along with this stuff. So you technically wrote some more code, but your iteration loop is tighter. And so you're saving stuff in the long run. I'm a big believer that better tools, and that could be level design tools, or it can be tools for programmers. Better tools let you make games faster, not just let you make games better, not just make games faster. And I think you all intrinsically believe me as well. Some of you are probably a little bit skeptical still. You're still adding more code, Andrew. It must be slower. And I'll ask you, do you hire programmers based on how fast they type? No one does that. No one sets typing speed as a test in their programming. We don't care about how fast you add your code. We care about how good your code is. You're going to spend the vast majority, the lifetime of the vast majority of code in your code base is going to be spent reading and maintaining code rather than writing it. So we've dispelled some myths. Let's look at some of the benefits. We've got tighter integration. That is iteration. That's what we just talked about. So really, really tight iteration. We're going to come back to that a few times in this talk. We've mitigated risk because we've taken all these bugs and we front-loaded them. Producers love front-loading risk. If you go to your producer and say, I really want to do some automated testing, it'll front-load risk. They will be so happy. Their eyes will light up. The main code base is just more stable. Your builds are more stable. You can test things earlier. You can test things out of a drop of a hat. You can take that big beta that we all have at the end of our projects, a big beta, so you can go through and fix all the bugs, and you can start crunching that down because there's less bugs and fixing those bugs is faster anyway. And maybe in a platonic ideal automated test game, like something like Sea of Thieves did this, they just stop. They just compress a button at any one time. They know that trunk is basically shippable. and it goes straight to Xbox Live. Xbox Live, no one says that anymore, do they? And it empowers QA. This isn't about reducing headcount. This is about freeing up QA to do the things they're really good at, finding hard to find repo cases or doing exploratory testing. I'm going to show you a graph now that my producer Drew provided me from the last 9 months of Rollerdrome production. It's going to show open P1 and P2 bugs. And this is a 25 to 30 person team over 2.5 years. And right at the peak, we're looking at there like 130 P2 bugs. I think anecdotally, that's pretty good. We haven't got a control case. I think anecdotally, for a game of this size and scope, that's a pretty good number. But look at the P1s. We never break like 10 for a huge, we get to the sharp end of console certification and we start going up and around 10. But until then, it's really, really low. The game is so stable. These bugs just aren't getting logged because the game isn't crashing. The game isn't throwing exceptions. The player experience is not being broken. So I hope I've persuaded you all. Let's look at a few steps so you can get started. The first thing you're going to need is, we've talked a bit about this, a build server or continuous integration server of some kind. You want this to be giving you, to be doing builds regularly. You don't want it to be when you remember to press the button. You ideally want it to be all the time. And you want immediate feedback for that. You don't want to have to remember to go and check the tab. You just want a push notification in Slack or an email or something to tell you that that build has broken and you need to go fix it. Shrinking that iteration loop, remember. And you need a test framework. All of the big engines these days come with first-party test frameworks. There are third-party ones you can use as well. This talk won't go into specifics about any particular framework. I am going to show you some Unity code, but it's not going to lock you in. These concepts are going to be transferable. So we got this stuff set up. We need to change our mindset now. We need to get into an automated test mindset. And I would summarize that as fail early, fail hard. And the first way that's going to manifest in your project is we're going to turn on warnings as errors. I hope I'm preaching to mostly the converted in this room, but for those of you who aren't, you're probably thinking, yeah, but most of those warnings are harmless. And we all know there's going to be 1 or 2 warnings in that big list of 10, 20 warnings that happen every time you build your game. There's going to be some there that are really serious. And yes, you're going to have to remove some unused variables that are harmless. I think that's a worthy price to pay for knowing that there's no hidden demons in there. So we got warnings as errors on. Now we're going to take that fail early, fail hard mantra and we're going to apply it to error handling inside the game. If you have a no reference exception and you're fixing a bug, we're not going to just write an if null around that thing and resolve the bug. Yeah, that's going to be really quick for you. You've got one more bug resolved, fantastic. But that no reference is going to propagate through the frame. In a day or a week, it's going to come back to another programmer because they've got that no reference appearing somewhere else in the frame and they have to go work that backwards and figure out where it came from and if it's even valid to be null. Much, much easier to just deal with it where it is. And you might be thinking, Andrew, I just want my game to handle errors gracefully and carry on because I'd rather, if the worst happens when we ship the game, that people can just like keep having their experience and not notice anything going wrong. And I would say to you, if you do this, if you fail early and fail hard, then by the time you ship your game, you won't have that situation anyway. That we didn't have that with Rollerdrome. It was very, very stable through the development process. You've seen that. But then when we launched, we had almost 0 technical issues come up. We were 60 hertz on 2 consoles and PC, and we had no big post-launch issues. We did do a post-launch patch. We did that mainly to address balancing issues. And then we were like, should we fix any code problems? And we fixed one bug, which was a roll animation that played like failed 1 time out of 10 in a particular situation coming out of dive. It was really, really stable launch. And we were doing this the whole time. We were failing early and failing hard. So the next extension of that is that if there's any test failures in your build servers, you're going to stop the build. You're not going to spit a build out. And again, some of you might be thinking, why am I, just because there's a health pack slightly misplaced on level 7, why are we stopping getting this build to QA and getting this build to play testers and designers? And I would say, either it's important that that health pack is there, or it's not important. If it's not important, delete the test. Don't have the test. That's fine by me. Remember, intention is your own. If you don't want to test that, don't test it. But if it is important, then by the same logic that we've used so far, let's just fix that test. As soon as you allow one test to become an advisory and let it just limp on and fail for build after build, then soon enough there'll be 2 tests failing, and then there'll be 3 tests failing. And before you know it, you've undone weeks of work getting your test system set up. Okay, so let's move on to the first thing that we can look at. The first thing that we did on Rollerdrome, these are validation tests. The difficulty here is 1 spicy chili out of 5 spicy chilies. This is going to be a relatively easy one. It's going to answer these types of questions. Can I open every level in the editor without errors? We've all seen those warnings in Unity where like missing mono behaviors of badly set up materials, or map check errors in Unreal. Are they there, or can we pretend, or like, are they all gone in the current trunk source control? Does every level have exactly 1 start point? That seems like a reasonable thing to test. It seems like it would be bad if there were 2 start points in my level. Let's just make sure that never happens. Are all enemies set to the right layer? Imagine the entire suite of bugs that you've just stopped from ever happening because you know that every single build, the enemies are always going to be on the right layer. In every build, all of these things will be true. There will only be 1 start point in each level. All the enemies will be on the right layer. It's really powerful. And I'm going to show you it's relatively quick to set up. The only thing you need is your test framework will have a way, you just have to go and figure out what it is, to take a test, 1 test, and then find all the pieces of content that apply to that test and run it once on each of them. In our case, a test that looks for start points, and we're going to find all the levels and run that test for start points on every single level once. In Unity's test framework, that looks a bit like this. This is an IEnumerable level definition. It's basically getting a list of all the levels in the build levels, all levels. Look, a bunch of boilerplate, that's the only important bit. So now we've got a list of all the level definitions. We can make one of these, which is a test fixture. A test fixture is just, in this testing framework, just means a class that collects a bunch of related tests together. So this is a test fixture of type source that takes that big list of levels, and then each constructor has a level definition, a singular level definition. And when we start to run the tests here in one-time setup, then we open that level definition in the editor. That's all we're doing. We're opening it in the editor. And then we can finally run a test. All of that boilerplate and setup. Here's the 3 lines of interesting stuff. You only have to do all this stuff once. We're going to find all the spawn points and make sure the spawn count is equal to 1. That's it. And when you run it, that looks a little bit something like this in Unreal. This is Rollerdrome. In Unity, sorry, this is Rollerdrome. You can see we're in the edit mode tab of Unity's test runner, which means these tests run without running the game. We've got a bunch of level validation tests here. You can see they've got every single level. Here's the powerful thing. As soon as the designer has a first draft of a level and they push it into source control, the build server already knows how to test it. And it's already running these tests against it. We're going to select a few and run them. It's going to be really quick because all it has to do is open the level in the editor, run some checks, and it's done. And we see we've ticked all those off now. We know all those things are correct about this level. All the stuff we've talked about, that there's exactly 1 spawn point and so on. Every single time. Really, really quick. That was 2 seconds, I think that took to run those 2 levels. And that's it. That's it. You've now got some automated testing in your build. That took like a few hours to get set up, to get running on the build server. Really, really easy. It's really low maintenance because probably you're always going to have to want only 1 start point in your level. That assertion is never going to change. If the way your start points work change, you've only got 1 test to change. So it's very low maintenance. And it's easy to extend. That big list you saw was something that grew organically over time. As we found bugs, we were able to evaluate those and say, does this fit a validation test? Can we put a test in to stop this bug ever coming back? And it executes really fast. In practice, on our build server, the validation test step took about 2 minutes, which 99% of that is just the time to boot Unity. And then running the test is extremely quick, which means we can do this every single push. Every single time someone changes something in source control, the server can be giving them feedback and telling them things are okay, or giving them feedback and telling them things aren't okay. And remember that iteration loop, it's tightening that iteration loop down there, giving you feedback as soon as possible. That seems reasonable, right? This seems like a doable thing that we can all go and do, and we can call ourselves automated testers. Let's do one more thing. Let's keep going. So this is smoke test. This is 2 spicy chilies. Smoke tests in Rollerdrome answer these kinds of questions. Will every level load in-game without error? Will every enemy type spawn without error? Maybe there's a problem with the way the prefab is set up. Maybe there's a problem with material or whatever. But does every enemy load right now in some way? Does every weapon fire without error? Are the bullets all set up correctly? Those are the type of questions it's answering. But it's a really vague question, right? We don't really know what's going to go wrong with these things. We're really just looking at the console output and saying, is there anything in there, is there any warnings or errors in the console output that we can fail this test based on? And that's partly because you remember we talked about the initial definition of test about accuracy, and accuracy means no false positives. And because we're testing such a huge suite of code, like level load is going to test the assets in the level and the logic of spawning the player, and it's going to test the actual level loading code itself. It's going to do all this stuff. We don't know where a bug might come from, so we have to write a relatively generic test case for this stuff without error. That's all we can really be specific about. The prerequisites here are the same as basically validation tests. We still need that way of running one test against multiple pieces of content, except now we're going to be running it at runtime. So we need some way of calling the level load loop from within a test of, I'm not preferably, I would really think you must be calling the exact same code that the player is going to call when they load a level. You don't want a situation where the build server is saying this level is loading fine, but it's failing somewhere, actually failing for a player in a real build. Once we've got that, we can start doing stuff like loading real levels into tests and doing things with them, or we can load test levels where we've isolated one particular scenario and tested that. In Rollerdrome, the level smoke test looked a bit like this. We're now in the play mode tab here of Unity's test runner, which means these tests run while the game is running. And you can see, again, we've got all the levels. And again, as soon as an artist adds a level to source control, it's being tested. It's being validated. You'll have noticed inside those test folders, there's actually not that many tests in there. All we're going to do, because we can't be specific again, so what it's going to do is load, check the console. It's going to run around the level for a second, check the console, and then it's going to quit back to the main menu, check the console. Because we're running, things are going to be slower. The bottleneck here is mainly going to be the fact that you have to boot Unity itself. You have to actually load through your own level loader. You can see the level loading now. We're loading into 2 Canyon. The test knows how to tab through these UI screens. And then all we do is press, so it's already loaded and it's checked that there's no errors in the console. So it's passed that test. And now it's seeing if the level runs. There's no AI here. There's nothing advanced. There's nothing big you have to invest in. All we did was push forward on the stick and wait 6 seconds. And we found that that exercised quite a lot of level logic. It's going to run the second level. One thing you may have noticed is we're very proudly a 60 hertz game. We put a lot of work into making it a 60 hertz game. That doesn't look 60 hertz to you, does it? We come back to determinism. We need these tests to be deterministic, which means we don't want them failing on your machine because you've got a crap machine that runs at 49 hertz and passing on someone else's machine because they run at 90. So we just set up one line call to Unity, which makes it pretend it's running at 60 hertz, no matter what your machine. So on my potato laptop, it runs a little bit slower than real time, but it still thinks it's running at 60. On someone else's better dev machine, it might actually run faster than real time. And you can see there, it loads, it runs, it unloads. There's these tests are to do with narrative levels. These aren't narrative levels, so it didn't run them. And that's smoke tests. So we've gone from like a few hours of setup to this is maybe a day of setup. You have to get that level load working. You have to be checking the console. We're testing a lot of code across the whole code base. So our tests have to be super vague. You probably won't have many of them. You'll have many, many validation tests. We'll probably only have a few of these big sweeping smoke tests. Because they're runtime code, they're slow to execute. At the end of Rollerdrome, at peak maturity, the level smoke tests took about 30 minutes to run on the build server. It's a long time, but paradoxically, it's the same thing as writing more code to get faster. We're slowing things down to get a faster iteration loop. And because of that, we weren't running these on every push, but we're still running them on every hour. That meant there was a big push within the studio not to just commit stuff and log off for the day, because the build server will just stop spitting builds out in the morning. If you've committed a bug, The build that will come in at 9 a.m. and the 3 a.m. build has not run and not completed. So instead, we preferred people to commit just as they were going, little commits all the time. That's obviously just good practice anyway. Then on top of that, if you get to the end of the day and you do have stuff to push and you really want to leave now, just leave it on your machine. It's probably not going to catch fire. It didn't. No one's machine caught fire for the whole of Rollerdrome. You could stop here and you've got some really useful automated tests with minimal effort and hardly any ongoing maintenance. But I want you to go further. Before we get to the next bit, a little diversion. I want to talk about tests that you shouldn't write. I've talked a lot about tests that you should write. I'm going to talk about some you shouldn't write. So if we think back to our definition of a test, which is a developer-owned automation that accurately verifies a feature works as intended. What about, let's consider this test. We all know what game this is. When the player fires a blue shell, it races to the front of the race, explodes, and spins out the race leader. That seems like a good test. We don't want to make a build where the blue shell isn't working. So let's put this test in, right? Let me ask you, why might this test fail? Well, okay, I'm going to rhetorically ask why this test might fail. That was my fault. It might fail for all these reasons. It might fail because the race order is returning the wrong value, giving you last place instead of first place. It might fail because someone's messed up the explosion code. It might fail because the car is not reacting to explosions right now because it's swapped layer. All of these reasons are nothing to do with blue shells, but we failed the blue shell test. Remember, we don't like false positives and false negatives. So we've introduced a false positive here by containing too much code under test. Remember, when we were doing our level smoke tests, we had a huge amount of code under test, so we had to write really vague tests. Here, we're trying to write something really specific over a very large amount of code, and that's going to cause problems. Secondly, I want you to consider who owns the blue shell as a feature, because it's not a programmer. Probably a designer. Well, yes, a designer is the one responsible for making sure the blue shell is fun, making sure it's balanced. Maybe they handed a spec to the programmer. Maybe a programmer typed some stuff in to hook some things up. But I think we all aspire to work in the kind of studio where you can just pass building blocks to designers and they can click together blue shells by themselves. So who owns the blue shell? It's not the programmer. And we talked about developer-owned tests. So it's not developer-owned, and it's not trustworthy. I don't think this test should exist. We could teach designers to write the test if you really want to. I don't really want to try and tackle that, especially on your first automated testing project. So instead, what can we do? We're not going to have this. Instead, we're going to break it down into other tests in areas that programmers do own, knowing that explosions can hit cards, knowing that when the player fires, their current item is spawned. That's really specific stuff, which is clear, which probably won't change for the lifetime of the project, and which is programmer owned. These are the sort of things that should exist instead. But you still want that blue test, don't you? You still would rather not be shipping a game where the blue test was broken and the test didn't tell you, and the build spat out even though this thing is obviously broken. But I'd ask you, what does a build with a broken blue shell but with passing tests look like? And I would argue it probably looks unfun rather than broken. It's not, it might be targeting the second player instead because someone set it up wrong. It might be not spinning carts out because the damage value isn't set correctly, but it's still working. It's still doing something. You're not getting exceptions in your console because all those other tests are passing. You're not getting QNANs propagating through your character rigs and stretching fingernails off to the horizon. You're not getting physics bugs where cars are glitching through each other and under the track. The game's basically working. It's just a bit crap. And I'd rather have that and rely on our human QA to catch those issues. That allows us to focus on maximizing ownership and maximizing accuracy. And I'll give you an example of why this goes bad. We actually had a very similar situation to this on Rollerdrome. We had a test that said when enemies explode, the player gets damaged. That was a test that a programmer wrote because designers don't own that stuff. Then very near alpha, we were balancing some stuff and that test started failing. And I think it was late in the day. I was probably one of the only people online. I was trying to figure out why this test was failing. And it turns out it's because the designers changed it to make the explosion not hurt the player anymore. They had no reason to tell the programmers that. It's their job to change that thing. But we had this, I had my day interrupted. I had my iteration loop stretched out again. You want to keep these iteration loops tight. You don't want these bad tests hanging around. So with that context then, the last thing we're going to look at is ring-fence regressions, the last area of Rollerdrome testing that we did. It's harder. It's 4 chilies now. So we asked ourselves, we had data validation tests telling us that levels were basically okay on disk. Enemies were basically on the right layer. We had level smoke tests telling us things are basically running okay. What else feels fragile about this game? What's breaking a lot? What's hard to work in? And the answer for lots of people was the player controller. Remember I said this is Doom on skates, or Tony Hawk with guns. So there's lots of states here, lots of modal states the player can be in at any one time, and tons of transitions between them. You can go from a wall ride into an acid drop, or vert into a grind. Tons of different ways, different edge cases, different things that could happen. It was becoming increasingly hard to test all of these things when we were adding new features. We were breaking stuff all the time. And so we got to the point where we would say, okay, we're working on a 6-week milestone. In the last 2 weeks of the milestone, we shouldn't really be touching the player controller because we haven't got time to find those bugs before the end of the milestone that we're going to introduce. And that sucks, right? The player controller, basically half of the game, and we're saying for 1/3 of our dev cycle, we can't touch it. That's really sucky. So instead, we said, no new fixes will go into the player controller. We're going to put a ring fence around it. And if a bug happens to land within that ring fence, we're going to put a regression test in with the bug fix. Regression test, for those who don't know, it just means a test that verifies a bug is fixed, a specific bug. So we're going to put a regression test in with every bug. The problem here is that we made this decision in the middle of development, and this code is somewhat hard to isolate. It's the player controller. It needs the animation system to be around. It needs the Unity physics system to be around. It's very hard to extract, say, just the vert code out and test the vert code by itself, unless you'd structured it to be like that from the start. So we're back in that situation, the blue shell, where we're writing a specific test, but it's over a huge amount of code, which makes it untrustworthy. You can imagine there's a big black box representing the player controller, right? When you've got gamepad input on one end, and then you've got animation state and vector freeze and transforms coming out the other end. Huge amount of code in there between those two black box walls. So we had to make efforts to shrink that as much as possible, knowing that we would not be able to shrink it as much as we would like. It was a compromise. The folks at Rare who worked on Sea of Thieves did a lot of automated testing. They have a specific term for this type of test. They call them actor tests. You can look at good talks by people like Jessica Baker or Robert Masala where they talk about this. I'll have links at the end where you can find that stuff. So our actor tests have to be really, really trustworthy. How are we going to shrink this box? The first thing we're going to do is copying example level geo or problematic level geometry out of levels into a test level. And you end up with this thing that looks like a big, messy gym. We've just got lots of bits of furniture around. And what you can do is start placing level spawn points in specific places. So it might be a spawn point here right before this quarter pipe, where if you just spawn and walk forwards, you're going to go into vert. And that's going to let you test some stuff about the vert code in that situation. This also means that level designers can go and change their level. Artists can redo meshes and not have to worry about breaking our tests. We're still working on the same underlying code. We're going to simplify the input as much as possible. That's this side of the box. We're going to shrink this down as much as possible. And that looks like, instead of trying to mess around with the gamepad, we're going to just try and poke stuff straight into the player controller and say, hey, you heard a jump. Hey, steer forwards. And we're using those spawn points to try and line ourselves up. So we have to do a minimum amount of input. Just really spawn yourself and it should be reproducing the bug. Have to push forward on the stick. Maybe sometimes we have to time a button press, which can be some logic to do with going into the air and then doing a trick or something. We didn't have AI. We didn't record user input. We didn't need to do any of that. We could get away without it. And you can too. On this side, instead of looking at vector freeze and animation data, we're shrinking this right down and we're just looking at the world state. We found that, at the player state, sorry, we found that because we're dealing with transition problems, almost all of these are transition problems, that we can simply look at the current state of the player controller and get enough information to exercise the bug without having to look at wall positions. And that gives us a lot more freedom when it comes to handling being rebalanced or anything like that. And that looks a little bit like this once you put all those pieces together. So we've got a test here. It's a coroutine. We spawn at a particular spawn point. We ended up with this nice little domain-specific language made up of other coroutines, where we very quickly put together the way to exercise the test. We're just pushing off, which means running forwards on the ground. And then we're waiting until we're in the air. Hopefully we're going up a quarter pipe or something. And then we're going to check, assert that roller state is not airborne vert. And that's all we need to do. And that exercise the bug, and then we could go and fix the bug and commit both the test and the bug fix. And that looks like this when you're looking at it. So we're in play mode here. These are the vert tests. So a bunch of vert geometry all around, a bunch of quarter pipes. And this is probably what most people imagine when they think about automated testing, is the game playing itself, looking for problems. Here it's playing itself and looking for bugs that we've already verified or fixed. Lots of different things here, like plonking down out of a quarter pipe onto flat geometry and making sure that you roll off in the right direction. Here's a really good one, transitioning from a high quarter pipe to a low quarter pipe. That was such an easy one. That kept breaking all the time because there's so many different ways you can transition through quarter pipes, and it's such a hard thing to keep testing. But once we had this test case, every single time we made a change, if the build popped out, then we knew for sure this transition was still working. So soon enough, not only were we doing bug fixes with tests, but we ended up doing almost all new features in the player controller with tests. We're still inside that ring fence, but we're doing all the new features. And that's partly because this turned into a really, really handy dev tool. When you're talking about something like the player controller, where exercising the feature that you're working on or the bug means finding a specific level, finding a specific piece of level geo, and timing some inputs correctly. If you can just boil that down to a test that you can double click in the test runner and then see it do it itself, that iteration loop is again getting really, really, really small. You can be dropping in breakpoints and logging really quickly. I'm going to show you another graph now. This is the last 9 months of dev on the project, all the open P1 bugs on the player controller. Unfortunately, we didn't start tracking this data. I don't have the before picture of this, but I think the after is quite stark. This is all the P1 bugs. Basically half the game. And this isn't created. Again, this is open. We hit 3 bugs on this day, and then we fixed them. And then I promise you, we were working on the game in this big period here between November and April. I promise you we were working on the game. And no P1 bugs came up. Nothing made it into QA's hands that they classed as a P1. I think that's a really good testament to the stability of the game. Very quickly, the player controller became one of the most stable parts of the game. We were able to drop that requirement on not working on it. In fact, we were able to work on it later than almost everything else. We were doing some optimization very late on in the project. We had a hypothesis that if we changed the physics time step, we could save some frames. Now, as the lead programmer, someone comes to me and says, can I change the physics time step? We're going beta in a couple of weeks. I would be like, no, we're not. We're just not even countenancing that. Find it somewhere else. But we had the tests. So we made the change. We ran the tests. Like 5 tests failed. That was it. And Chaz, who's here in the second row, went carefully through all those tests. He spent like a day and a half going through them with a fine-tooth comb. And he came back to me and he said, I think they're just bad tests. And he justified it to me, and I agreed with him. We rewrote the tests so they were better, and they passed. We made test builds for QA. They said it felt the same. The test said it felt the same. We made the change. We saved the frames, and there were no knock-on consequences. We already talked about how smooth the launch was for this. So to summarize, actor tests here, they're a much bigger job than your level smoke test and your validation test. It's a continual thing, not a thing you do once. However, you've seen what the payoff can be. The type of tests we're writing are as small as, like, as little code as possible. We're really crunching that down, but they're super specific tests. And because they're runtime, they're slow to run. The player tests, by the end of the project, we said that level smoke tests took about 30 minutes. The player tests took about 30 minutes as well. We also ring-fenced the enemies, the exact same process that we've gone through here. That also took about 30 minutes by the end of the project. So you're talking about 90 minutes. But again, it's paradoxical, but you're spending more time and saving time, tightening that iteration loop. So my challenge to you after this talk is I haven't told you really, I've told you things you should be excited about, but I've not really told you how to first line of code. Keep learning, go from here, look for resources, read some books, watch some talks. And it's a discipline. don't get put off when you start writing tests, because initially you're going to write the wrong tests at the right time, and you're going to write the right tests at the wrong time, and you're going to start to think this is all a waste of time. So keep learning. You can find all those. If you go to Auto Testing Roundtable, you can find a Trello board maintained by a guy called Henry Golding, who worked on testing on Minecraft and a bunch, and Sea of Thieves, I think. And he's put together a huge Trello board with talks and books and lots of good stuff. So to summarize, bang for buck, a la carte automated testing exists. You can do a little, or you can do a lot. You can do it late in the project, or you can do it early in the project. But you can do whatever you want, and you can still get some return on investment here, even if you only want to spend a day on it. You should fail early and fail hard. You can do this bit, even if you don't do any tests. I still think you're going to end up with a better game at the end of it. We wrote on Rollerdrome some validation tests that look at data on disk and make sure the data was set up correctly. We did smoke tests that asked general questions about the state and the health of the game when running through basic operations. And then we used actor tests to look for specifics and to exercise stuff that we thought was particularly vulnerable. And here's those links again. My blog has some stuff. If you're testing, we didn't cover it here, but if you're running automated tests on a build server on AWS, I've got really useful stuff on my blog. That turns out to be very hard with Unity, but I've solved it for you. And you can find me on social media. Thank you. We've got a few minutes of questions. We've got some microphones to pass around if anyone's got anything they'd like to talk about. Or it's the end of the day, it's the last talk, we can all just go to the pub. Throw your hand up if you want to ask a question. Oh, one at the back.
Hello, you talked about having errors as warnings and how you would not spit a build out if you got any errors or warnings. In Unity, so we all know that, especially when using experimental packages, Unity itself can spit out seemingly random warnings and errors. How did you get around that without whitelisting enough errors to reduce accuracy and confidence in your own tests that were passing?
We didn't find that specific problem too much. Plugins were more of an issue. Plugins seem very happy about
or middleware, like
middleware stuff,
like that, yeah.
And in that case, we would almost always go and put a very obvious row 7 comment around it and then fix the warning or put a pragma around that one thing. And that would fix that individual warning. We have to do that a couple of times. Normally, you're just doing this to the point where you integrate a plugin. You have to be very careful then when you merge your update your plugin later. It wasn't a big cost or a big downside for us.
Okay, thank you.
Hi. On the test that you showed as a sample of for doing the verts, there's a push off and then wait to be in the air. Is there an automated timed failure? So if it never actually got into the air, the test would fail, or would it just sit there forever until someone noticed?
No, yeah, it would an automated test. There's an automated timeout. So Unity's test framework, I think, times out at 300 seconds. You can add attributes to make it time out sooner. Actually, the big problem we found there wasn't so much that the individual tests would time out, but the build server would just, if you're in a situation where that's happening, where tests are timing out because there's some fundamental problem, the build server would just run on for hours and hours and hours and hours, and it's not giving you any notification to say this is taking ages. So then we added a failsafe that said if the build takes more than 1 or 2 hours, then we would fail it and then post into Slack immediately, and then someone can go and check that out. But then if you force kill Unity, you don't get any test outputs. You don't actually know which test was failing or which test was taking a long time. That was a bit of a pain. One way we ended up tackling that was splitting up the groups into different test runs. So we would boot Unity and run the level smoke tests, and then we boot Unity and run the player tests, and boot Unity and run the enemy tests. And that meant we could at least isolate it to one specific area that, like, the levels are, for some reason, stalling right now. And then we could run it locally and see what the issue was.
I guess you could have used something like a syslogger as well to push the log output to
Unity just doesn't spit the log out.
I mean, outside, write something that does it via networking. That's your own crafted thing to do that.
Yeah. You can look at it that way.
Hi. obligatory, great talk. Thank you. Important subject. You talked about it being developer owned. What are your thoughts on providing a test framework for designers, specifically, for example, a puzzle game, and making sure the puzzle is soluble?
It would be a really interesting problem. I think it would be really great develop talk next year.
Challenge accepted.
I think we're out of time now. Okay, great. Thank you very much, everyone.